Okay. Yes, I remembered to press record today. I set an alarm and everything so that I remembered. So recording's now on, so we could get going with this morning's delegate assembly. Today we're going to have Sylvie present the notebook that she's been working on for Data Preview 0. So right now I just have, we have this slide up that Sylvie made for you to make sure that you get the notebook that she'll be going through today. So we're just going to sort of pause here on this slide for a couple of minutes, let everybody make sure they can do a git clone of the delegate contributions DP0.1 repository, and feel free to like unmute or post in the chat if you have any troubles getting this notebook. I see like a lot of people probably also had alarms set for 9 a.m. and a bunch of people just joined as well. So if you're just joining us right now, just, oh, maybe I should go. If you're new, which you might be, you want to log into the Rubin Science platform. That's the very first thing that you do. So if you're new, because we did just manage to welcome a whole bunch of new delegates to Data Preview 0. So if this is your first delegate assembly, welcome. We usually start out with just sort of everyone gathering for the first 5 minutes, log into your account at the Rubin Science platform at data.lsst.cloud, open up the notebook aspect and get yourself all set up. If anyone is here and you're totally new and a little bit lost, you can unmute and we'll help you, or post in the chat. But generally, I'll just give you time to get your server spun up, get yourself logged in, open up the notebook aspect. I'm going to go back to those git clone instructions. You can make sure you have the notebook for today. Also, you should be able to see my screen with the slides, right? I don't have the green. Yeah, okay. It doesn't look like it's screen sharing, but it is. And I'm also just going to put the git clone command right in the chat so that you have it if you need it.
It's not in presenter mode, it's in edit mode, but.
Oh yeah, that's okay. Yeah, it's just usually when you're screen sharing, you get that nice green box and it is gone. Okay, so while people are getting themselves logged in to the Rubin Science platform, the notebook aspect, to git cloning the repo if you don't have it already. If you did do the git clone last time we were all together for the last delegate assembly, you will have to update it. You'll either have to update it with a git fetch and a git pull to make sure that you have the latest version of the repository that contains Sylvie's notebook, or if git's not your thing and you don't know how to do a fetch and a pull, you just blow the whole thing away, or rename it or something and then do another git clone. It's not as efficient because it'll get you a whole new copy of everything that's in the repository, but it will get you today's notebook. So that is also an option. So again, just post it in the chat or unmute If you have any questions about how to get set up. Okay, and while we're letting everyone get their servers spun up as well, we can talk a bit about breakout sessions. So after we have our formal presentation, we'll do some delegate profiles, the little 30-second introductions, and then we'll have some breakout sessions. So if you have any ideas for breakout topics, things you want to discuss, things you want to work on, we can add that to our list of breakout sessions over here. And Tom, the notebook you're going to use today is this one. Put it in the chat. Will be in the structure from track directory. In the and you'll know you've opened the right one because it'll look like here. Somebody's put a picture of it for you.
Here is a quick question. So I was trying to git clone it using the terminal aspect. I'm getting a warning that says, make sure you have the correct access rights. I did say git clone git at github.com/blah, blah, blah, Roman DP0, etc. So are we not supposed to be using git at github.com?
Oh, right. You should probably use the HTTPS version if you just want to grab it. If you
Okay.
don't have your Git set up. I'm guessing that's what the issue was. Let me just show. If you do have your Git like all set up, then so here's the.
Well, I thought I did, but I will try the HTTP version.
Yeah, the SSH one I think works better if you have Git configured at the Ruben Science platform. If you don't, the HTTPS version will always work. And it's just git clone and then use this link instead. So I'm gonna pop that in the chat. That's
and
good.
which one of those are we trying to get?
The HTTPS version should absolutely work for you. You don't need Git configured for that. Is my understanding of how Git works. So anyone else can chime in if they want to give more of a difference between the HTTPS and the SSH versions. It's a good question, Tansu. Thank you.
Yeah, thanks. By the way, it indeed worked that way.
And just in case we have any really new people here, and it's your first time and you've logged into the Ruben Science platform, when you first log in, it's going to look like this for you instead. If you haven't opened a terminal before, it's this one right here, this button here will open a terminal for you. And that's where you would do your git clone, etc. Do it in there. Just in case that's helpful. Okay, we're about to start today's tutorial. I didn't see any breakout topic suggestions so far, but as usual, we'll come back at the halfway point and collect any breakout topics that people want to do. So I'm just going to, before I hand it over to Sylvie, just one announcement for today, which is the same announcement that we have every time, just to give you an update on what we're doing in the delegate assemblies. So 2 weeks from now, we'll have the tutorial on image processing that was canceled a couple of weeks ago. So Andrew Bradshaw will be here from the Rubin Camera Science team, and they'll tell you all about image processing. Then that will be the last one. So December 3rd will be the last delegate assembly for the year. We can reconvene on Friday, January 14th, which is the Friday of the week of AAS. So if you're at the AAS instead, that's fine. You'll probably miss that one, but that's another opportunity for any delegates to present any of the work that they've been doing on DP0, any notebooks you have in progress, results you want to share. That'll be January 14th. And then sort of at the end of January, we have kind of a special session. January would be the halfway point of the year. So DP0.1 will have been going on for 6 months. So we'll do sort of a special session at the end of January, just summarizing how the year has gone. And at that point, we'll take a more of a look forward to the phase 2 of Data Preview 0 as well, so that people can start to plan. And then after that point, we'll continue to have delegate assemblies with people coming together to present their work, share work in progress, hack together in breakout sessions, do more delegate profiles, continue to network and work on Data Preview 0 and LSST sort of as needed. So that's what the future kind of looks like for our delegate assemblies. At any time, you can suggest to the community engagement team a topic that you might like to learn more about. We can always invite people from across Rubin to come and give presentations on any topic of Rubin you'd like to learn about. You can also at any time volunteer to present your work, and we'll get you set up to do that. That would be excellent. So that's the only announcement today. It's just a little bit of forward looking. I think I don't see any more questions in the chat. No raised hands. So I think we can proceed, Sylvie, with, oh, Greg's got a raised hand.
Just a very quick thing for non-Americans that this coming Friday we will not have the Stack Club meeting because this is a Thanksgiving holiday, but we'll resume again 3 weeks from today.
Thank you, Greg. Yeah, I forgot about that. No Stack Club next week. Yeah. Okie doke. I'm going to stop sharing.
Okay.
Sylvie, take over.
Hello, everyone. So I try to share my screen. I don't know if I choose my desktop or my notebook. Also, I don't know. Let's try this. Can you see my desk?
Yeah, we see your, basically your whole browser.
Okay,
yeah.
Fine. So perhaps I should make a very quick introduction from me. So I am a member of CNRS on IN2P3. And my institute has this name, Irene Joliot-Curie, IJC Lab, and it is very new. Before, formerly it was called Laboratoire de l'accélérateur linéaire. There has been a merging. So just a quick introduction. I am a member of DESC. I am mostly working on atmospheric calibration related to photometric accuracy, something like that. And presently I am working on data coming from the auxiliary telescope. I am also working on a PhotoZ pipeline, and I am interested in large-scale structure, but I have not done a lot So that's why I am doing this notebook. And just I would like to have a tool to find by hand a big structure, not running a big pipeline, starting from the tract and going from a top-down approach to find the structure just by looking by eyes in the view. And I wanted to use the HoloView tool, which is quite new for me. And we will see what we will have. We will have the plot shown before on the slide. This is a kind of goal. So, okay, we start. When we start, okay, I start from scratch, as you are probably. Restart kernel. All cells are empty. Output cells are empty, and I will run it. So first import, I don't go through the import. There are no special things about that. So import. Okay, it's done. Just a few things on the versions I am using. New imports. I set up some parameters. Okay, I will have also need. I will need AstroPI cosmology. Something to remove matplotlib figures. Just I am checking the version I am using for the DM stack. Okay, this is what I have used to prepare this notebook. And now we enter with something that I will describe is a notebook configuration. First, I need the username. So when you execute this command line, you will get your name here in this word. And in fact, you will see that we are preparing some paths because it will create in the Scratch directory some subdirectories under your name, and it will create what I call the notebook directory. And in that notebook directory, it's possible that you create some output files. So you do this, and here you create some output directories that are not in your home directories to prevent problems with the size. And when you come here, you have steering files. For me, they are true files. For you, they are all files. Perhaps the policy is that you all get files, because in fact, I am using some already written answer, tape answer. So, but if you save some intermediate responses from the tap system and you want to speed up, if you activate to true, it will go more quickly. So for example, so for me, this has been done. I ask for the tap service, as usual, as in most tutorials. And I start to ask to the system all the list of tracks that are in the tables, object tables. So I do this. Okay, so this is, I show the command. And here, this is the file name in which I will write the output of this. So if I run this, okay, it goes very quickly because given that I have a flag read set up for me, so it will find this file and it load directly from the directory. For you, no, probably you are through this and to make this call. So this is the list of the tract I find. I hope everybody has already tracked in a more readable fashion. You can see all the number of track ID available in this catalog, object catalog. If I want to have more information than track ID, I do this by this. In here, I ask for tract and I ask the statistic, how many objects are in this tract. So I launch the system. Of course, for me, I read from a CSV file. And I add a few items in the table, the index, and I compute the log of the count. So you should have, as in the table head, so you see the track number, you see the count in this tract, and the log of the count. How many tracts we have? 166. And we will start first a bar plot with all of you, just to it's a simple histogram, just to have an idea of the statistic. So, and I have indexed by it's not the track number in abscissa in X. It is the index I have created to have the first track, second track, and so on. And what is very interesting is when with all of you, you can see the track number, the index, and the count. And you see that most of the tract have around 1 million objects. Sometimes, and this is a very, you have non-empty, but all of you doesn't show you a very low number of tracks that have a very low number of objects. For example, here, this around 100 objects. So that's why I have computed the log of the track. And here I do a plot with a, yes.
Can I interrupt you for a second? Can we pause for a second? My notebook's running pretty slow, so I think, are you in section 2.4?
So I am in section 2.3.
Okay, yeah, and I noticed in the chat too, a lot of people's SQL_result1.
Okay.
So it's still processing.
Okay. So I wait because you know that's why I had foreseen that with some people it can be through the tab system.
Yeah, so I'm still in 2.2. Yeah, it looks like a lot of people's is still running. I don't know if we're all doing the same search at the same time, and that's maybe causing some delay or what's happening, but yeah, let's just pause.
Usually when I am alone, let's say probably from France, when I run the notebook, there are not many people connected, so it goes quite quickly, but I don't know how many we are connected. So the answer are quite, you have a small number. It's a short answer, but I don't know if it takes time to compute this.
Yeah, You don't seem to be having trouble executing the cells. For me, mine's stuck at the cell even before that one. It's still executing and having trouble. Well, we also have a question in the chat. If you could repeat cell 13, just below section 1.2, and maybe explain
Yes.
when it should be set to false or true.
So the goal of this cell 13 is to rerun quickly the notebook. So if you have spent some time waiting for some type response, here I ask for the first time I pass here the notebook to write the output of the query on disk. On here, the second, read. I allow the notebook to read the answer from what is written on disk. So if it is possible that everybody set this to true, they can run the notebook and it will be written, but it can take time to get the answer of the query. So if you want, you can activate this true. For the first pass, anyway, you will have to wait for the tab system to give the answer of the request. If you pass a second time and you want to restart your kernel, if you have this true, then you will not have to wait for the tab system. It will read the output of the query from an ASCII file, mostly an ASCII file, which will be saved in your Scratch username on this name, tract_LSS01. It will find it. I don't know if I should.
I think that probably answers the question that they're all set to false for now because we're not going to write any output files. But if you did to make output files, you could set write to true. And then if you do that one time when you're running through, then the next time you can set read to true, and then you don't have to do your query again.
For example, what I can show you is the following things. So I am in structure from tract, and if I do this, I make ls, okay, and you see that I have created under my account name this directory. So I do cd this, okay, cd tract, and all the answers of the tab system are written in CSV file. This is for me to run quickly the notebook.
And Sylvie, if you went to just cd/scratch, you could see other people's directories that have
yes, okay, Scratch. So we see people who have activated, so there's quite a lot of people. Of course, everybody has created this directory. If you go there, okay, if you go there, so you create the directory. There is no flag asking if you want to create a directory. So by default, if you run the notebook, it is created. It's just here. This is flags to allow to write file or to read files.
Yeah, cool. So and it's great to use that Scratch space. Not very many people were using it yet. So this is also like a good demonstration of how to use our shared disk space and a good reminder that everyone can see everyone else's directories in the Scratch space. It's a nice place to be able to share stuff. And we're getting reports in the chat. Thank you very much that the bottleneck seems to have cleared. Mine has also cleared. So I think I am now on section 2.3, so we can at least start from there, I think.
Okay, so here in section, I want to increase the number of information available from the query, and I have added this kind of things, a contract to. Okay, what I want to do is to count what I do. Count, return the number of objects. So it counts the number of time I get the track number. It is a kind of group by, it's the number of counts. So if you have finished this second query, and you see I make a histogram with all of you. And I can investigate the statistics per tract. And I have this histogram, which is linear in a vertical scale. And I can see on going through the tract, the statistics. So we see most of the tract have 1 million objects. And if you go to the second histogram, this time, what I am showing is the statistic in log scale. Well, in fact, I have taken the log of the counts. And you see that the tract number, for example, if you take the first tract number, 2007-23, so you see a bunch of tracts that has a low number of counts, while most of the other have 1 million objects. Sometimes we have some, okay, it's just to see, it's interesting. And so then I would like to compute the position of each tract in terms of right assumption and declination. So I put the average of right assumption, the average of declination, and I launch the third request to tab system. So okay, now I read from this. I take the answer. I add the log. And now, of course, you see I have the average at assumption for each tract, the average declination. So in fact, now I am trying to make a map. I am using the all of you elements scatter.
Wait, can we pause again because
Yes.
searches again. So I think we're
So
going to have to wait.
I wait if everybody can get this strange map,
Yeah,
because it is a simple map.
yeah, everyone
Very.
map, so we'll just wait until. And we have the full, like we still have the full rest of the hour for you. We did
Okay.
a second presentation today, so yeah,
Okay.
which is good.
Yeah, okay.
Okay.
So as soon as you have it, you
Yeah.
can play with.
Yeah, I think you can go ahead and tell us about the plot that you're showing while our search is.
So in fact, so all of you show you a scatter plot of where you show along x-axis average rate assumption of each tract on the average declination. So this is a map. The idea with that is you want to work on a tract, you don't know where it is. With this, you know where it is. So for example, if you take this tract, 3,445, you have its average rate of function and declination, and you have the total count number in it, so 1 million objects. And what you see, if you take this tract, it is on the border, and you see that it has a small number of objects. So basically, if I want to work with a tract, I won't take those in the borders. I will take, okay, I can go take anyone which is in a dark blue. Apparently, the color of the tract is linked to the statistic. Okay, maybe it can be improved. I hope everybody has this. I have also tried another things is to do the same plot with the all of you element called points. So there is a little something different. Here I have only the information X, Y. So it is more restricted. I am not able to put more information because I only provide the coordinate of the point. So the previous one is probably better. And I had in mind to compare with the official figure of DP0.1 in print. And what I wanted to do is to play with the butler also. So here I load the tract. So we can see, so this is from the paper of DP0.2. You have the legend. You can see that this is typically in red the size of the focal surface of the telescope. Here I want to discuss on this. So it is interesting to see. So for example, if I take this corner tract, 5074, in fact, it is here. Here in this, you have we have the axis reversed here. So we find this on the bottom. There are probably in the DP0.2 paper, we see that the 2908 is in fact here. So for DP0.2, this bottom line of tract has been removed in the paper. Okay. So what I have here is to ask some information to get the same information from in the butler. You ask for a sky map collection or object, and Margaret answer to me gave me a snippet to show how to make a nice plot. So to gain some time, I have not I have put if 0, not to execute it. If I do this, you will see. I hope what it will give. So it allows to plot this. Okay. And he has also nice code here to show the statistics in each tract and patch. You can play with this, it works for me. Okay, so, but now I have lost my notebook. Where is my notebook? Okay. So I prevent the execution of this because I think we will lose some time, but you can play later with it. You put 1 and you execute this. So now we make a big query. We will select a tract by its number, and we ask all this for all the objects in this tract returning the object IDs or attention declination.
Can I just,
So
Sylvie,
where
there-
I am, is it your question?
yeah, yeah. Oh, you skipped a cell and I didn't understand why.
To gain a little time. If you want, I can execute. It's just to have, wait, yes. You see here, this tract are not fully filled by object. There is only of the order of 100 objects. So if you compute the average declination, it is biased. So what I wanted is to get the geometry of the tract and patch from the system, the butler, not from the object table. Okay, that's why I wanted to introduce this interesting object. When now we are at the butler level, to call the butler, you ask for sky map, and sky map is able to provide you the geometrical structure of the DC2 independently on the own. So I won't detail, it's not my code, but I think it is interesting because I was looking how to ask to a sky map to provide me the list of tracks. So it was very simple. When I have created previously a track list, and now when I loop on the track number, I am able to find this sky map, the information related to this tract, and we are able to plot it.
Yeah, my question was, why was the cell skipped? I was wondering if so I executed it to see if it takes a long time. I didn't know why it was skipped.
Yes, I was afraid that it would take some time, but
It right away.
because I waited some time to do it. So let's try.
It took some time. Okay. Yeah, I just set the 0 to a 1 and executed the cell, and it did it right away. So I was just wondering why you had made it a non-executable cell.
Yes, it's taking some time.
So people can go ahead and execute that cell. It's not, makes it.
Yes, so I have it. Okay. Because if I had 25 minutes, it was okay. Now the big thing is we are at level 4, section 4, work at patch level. No, it's a mistake, it's a track level. Okay, now I need a tract number. I build a query and I will ask objects in that tract. So I run this cell to have this function defined. I select this tract number. I build a query. Okay. So this is long query. This is, but I have saved my result previously in this. If you are running, you don't have this file, so you will go through this these cells. So I run, and it goes quickly. I don't have to wait because it's already there. So perhaps I have to pause. And I wanted to show you that in my notebook directory, you see that this big files, the pickle files, have all objects, and it has it's big. And you see here. So you get your result in track data, which is a Panda table. And I stop here until you say me it's okay.
Yeah, my job phase is still pending, and probably many others who executed the call the job cell, their job phase is still pending. If I remember right, it's like only a couple of minutes, I think, for the job.
A couple of minutes, yes. But again, the point is that if everybody is asking the same thing, I don't know.
Oh, and maybe in the chat, it sounds like some people are still running the cells under select the tract number. Oh, which might have run faster for me because I already had the PKL file.
Perhaps in next session, I would ask people to run the full notebook, write files, and then restart on reading from restarting perhaps to gain some time.
Yeah, we could do that, or we could just use one of the breakout rooms and you can keep going with the rest of the notebook.
Okay.
I can't remember how long it took to.
It's the last query, almost the last query. Because after I have added an optional section, which is to get an image from the butler. So if you want to make some profile on
Yeah, it looks like some people's jobs are executing. Mine is still pending.
You can't tell the job status by what's printed below.
Oh,
You have to click the link to get the status because it just prints the job status before it goes into the job.wait, and that will always say pending.
oh, that pending never updates.
Correct.
Oh, I see. Okay. So if I click the link.
so if you execute this cell, you see if you have this result for file.
Mhm. Oh, at least Simon said, okay, great. That's good to know. Simon says finished. So maybe just we'll wait one more minute because if people's jobs can finish and they can follow along, that's probably better. Do report in the chat if yours has also finished, so we know whether we can move on. Or is anyone else, are other people still waiting? It's a yes, still waiting. I'm a yes. Okay. Still waiting. Yeah, still running. Okay, yeah, I'm not the only one. Yeah, still executing. I'm also not sure, Simon, when I do follow that link and it tells me stuff about my job, there's nothing really that says even that it's, oh, it just says queued. Oh, mine is still queued. So it's not even started yet.
Oh.
Ah, I see. So given that mine has not even started yet to go, maybe we should move on actually. I
One
won't-
thing is that you can copy, if you copy all the results that are in my account, in my Scratch, you copy all these pickles CSV file, you kill your notebook and you restart, and you set the flag to true, it could be the solution.
That's true. That's one way we could fix things. Yeah. But yeah, I think that would also take a long while for all of us to do that right now. So just one more question in the chat. When we click that URL, are we supposed to be seeing bare XML? That's what I see also. It's not formatted in any way, Tom. But I don't know if that's what we're supposed to see. Simon, do you know? Is it normal?
That's what the VO standard says to return. I mean, normally you would be interacting with this through a client that would know what to do with that information, like Topcat or whatever. But because we're actually looking at the actual service endpoints, there's nothing. I mean, your browser may try to do something nice with it, but that's about all you can do.
Okay, so this is not it's not an error. We just sort of look until we see phase and then you can see it's queued or whatever. Yeah. Okay. Yeah. So I'm looking at the row in that URL that says queued.
I mean, we could throw an XSLT on it and give the browser a little more hints as to how to render it, but I don't think we have. I know we have.
Yeah. And it's all the info is there, so we can still see the job phase. Okay, so since mine is still queued, let's all just watch Sylvie go through the rest of the notebook for the next 10 minutes, and then we can catch up in a breakout room after and try to keep
Okay. Okay, so then there is an element, the truth tab. The truth tab of the object. I replace numbers by names, as it is done in the tutorial, one of the tutorials. When you see your response as a panda table, okay, object ID, ADEC, the try, the patch, the way they are defined, like this. What I will need also, I have obtained from the redshift from the truth table. On here, I have only galaxies. Okay. No, I have everything. Here I drop objects that are not galaxies. I will do this. Okay. Now I want to view the patch ADEC. I want to like this. So I compute a 2D histogram for this tract. I show it in Matplotlib, so we see some structure because, okay, you are using histogram and you integrate on some RADEC to see some structure. I remove the figure and now I show it with all of you. And I follow to check that the orientation of the image is the same as the one in Matplotlib, to be sure that I make some mistake with flipping in the declination of the image. So we have the same image, and it is interesting that when we go through this image, The cursor indicates right insertion and declination. So it's good. Now, the idea was also to test different data structures that we provide to all of you. So let me execute this. So this is basically the same thing, but I am using the dynamical map and this data shader. And you see that, in fact, if you take the zoom box, okay, the point is that the square are transformed into points. It's not that easy to find structure with these dynamical maps. That's why I will concentrate on histogram. So I will show things through histogram. Here it is almost the same thing, using the points. Okay, so, but now I skip this CDS view because I have not done much with it. Now I am going to look at histogram. So what I am doing is building 2D histogram. This time with rate function and redshift to see if longitudinally we can see some structure. And so I create an object image. And it's strange why I don't see it. Ah, yes, because I have to go layout. So with histogram, you can see some structure longitudinally in redshift. I do the same thing in declination, attention versus redshift. Just quickly. Okay, so I see if I want to study this structure, I know what I can select. For example, if I want to study a structure, I know its redshift 0.8 and its declination minus 40.6. I will skip the 2D scatter. It doesn't bring something quite interesting. So here, let's do this. Okay, because I have reduced the number of samples. I take 1% of the sample of object. Now I have almost 10,000 objects, and I do the 2D scatter, and I am able to compare the right assumption versus redshift, declination versus redshift. But it is not easy to use this point. On the end, I am just showing a distribution of the redshift. Then what I wanted to, you interrupt me if I am too long, don't hesitate. But I wanted to transform these objects and to see in real space in terms of megaparsec. So I am transforming redshift into luminosity distance. No, it's not, or co-moving distance. Okay, you see now object in real space. And I found interesting to be able to see this image stacked one above the other. Okay, so you can compare. I see something. This is relative rate ascension relative to the center of the track. Okay. Then,
Sylvie, and this might be a good place to pause.
yes, I think.
Right at the end of section 4.5, got through some cosmological diagrams. This might be a good place to pause. We'll do the delegate profiles that are planned to do now, and then we'll have a breakout room. It looks like people's jobs are starting to execute. So anyone who wants to keep going with this notebook and make the same plots will be able to do that in the breakout room.
Okay.
So I think, yeah,
Let me.
we did some Cosmo plots that looks like people think are very cool. So let's all take a moment to thank Sylvie for the formal presentation that she gave today. Yes, that was excellent. We're learning a lot. Oh, good, and people's jobs are finishing. So yes, that was excellent, and we'll want to do some more. Good. Sylvie, open the chat if you don't have your chat open.
Yes, I have the chat open. Yes.
People are saying nice
Yes.
things. I want to make sure you.
Yes.
Okay. So we'll pause here for a moment. And we're about to do the delegate profiles. But first, I wanted to remind people that they can suggest any kind of breakout room that they want after this. So we'll have at least the main room as usual will be for open Q&A. Ruben staff will be here. So especially if you're new to Data Preview 0 or you just have any questions at all, we'll do that in the main room. I'll assign breakout room 1 for Sylvie to continue with cosmology and getting structure from tracks. And then if there's anyone here from supernovae or resolved stellar populations, those have been some regular breakouts. Okay, sounds like. Oh, of course, Louise, good point. Anyone here from large scale structure will want to be in breakout room number 1. So we've got resolved stellar pops. Maybe the supernova people will want to meet today. But we'll come back to this after the delegate profiles. So as you watch the delegate profiles, also that might inspire a few more breakout rooms. People want to get to know each other and hack on stuff. So let's skip down to our delegate profiles. And I'm gonna put this in, oops, nice mode. So as you see your slide, just unmute and feel free to speak, starting with Mike Rich.
Hi, thank you for asking me to present. I'm interested in LSST because of the stellar populations science that it potentially will allow, particularly with variable stars and work in the galactic bulge and Magellanic clouds and dwarf galaxies. What I show here is from the Blanco DCAM bulge survey, which is a 200 square degree survey of the bulge from the U through the Y bands, the LSST bands, that show how well U-I correlates with FE/H, and we've already derived abundance distributions looking down the galactic bulge at different galactic latitudes from -4 to -8 degrees. So we're very interested in doing similar and deeper science and exploring the age of the galactic bulge using the LSST.
Thank you, Mike. Next. Oh, Tensu.
Hey everyone, so Tansu Dailan here. I'm a test postdoctoral associate at MIT, and I have a visiting appointment at Princeton right now. I work on various aspects of time domain astronomy, but my interest in DP0 mostly stems from my recent enabling science grant on detecting moving objects, especially slowly moving objects with LSST. The idea being that if you have an interstellar object, we want to be able to find it as quickly as possible using as few data as possible. And we are trying to optimize a pipeline that can enable that. So good to see you all.
Cool. Thank you, Tansu. Alma.
Hi, I'm Alma from University of Guanajuato in Mexico. I'm a national researcher and I'm co-leading the Mexican contribution in in-kind to DESC, and I'm also figuring out a work plan for contributions to strong lensing. And my main interest in general science is constraints to dark matter, and so for Rubin, I would really like to find constraints from strong lensing. And I'm also part of DESI, so I'm interested in Rubin DESI synergies. And well, in general, I'm very interested in outreach and public education. So of course, I'm very interested in the DP0 investigations, and please count me in. In the plot, what I'm showing is a correlation function of laminar forest. That is the work that I do in DESI, and basically I work a lot with simulated data sets to find systematics. Thanks.
Thank you, Alma. Mariano.
Hello, everybody. I'm a professor in the ATE Institute in Cordoba, Argentina. I work on astrostatistics mostly. I have many interests on growing science, but currently I'm working on system of galaxy identification using supervised techniques, mostly incorporating the weak lensing information this time. Also, I'm very concerned on the impact of the satellite constellation on astronomy in general. And well, you have there are my contacts, and we have a project on the mountain, Andes Mountains, in a small observatory for time domain astronomy, and also building a machine learning and artificial intelligence center here. Thank you.
Thanks. Massimo.
Hi, everybody. Thank you. I am Massimo Dolor. I work at the Italian National Institute for Astrophysics. And basically, I'm a member of the STARS Milky Way Local Volume and TVS collaboration, but also of the formally of the DESC science collaboration. And I'm basically interested in near-field cosmology. I co-chair with Mike Rich the Crowded Stellar Field Task Force, and I am one of the people that signed for the Italian kind proposal, especially on focus on automated multiband PSF precision photometry to flank the official Rubin LSST photometry in the most crowded area, such as the galactic bulge. So basically, my main interest is in the Rubin LSST data is the structure and distribution of the galactic old stellar population, mainly using RRA variable stars as population tracers. My main interest in DP0 is to understand and to be familiar with the structure of the Rubin LSST data, to interface the Rubin LSST catalogs, for example, with other external analysis software, for example, WAS, which is a software to pinpoint variable stars and determine their, for example, their pulsation period. I'm also involved in other external projects. For example, I am a science team member of the Maori at European Extremely Large Telescope. And I also participate, but this is not my main business, at the NASA DART mission. Here you see, for example, a airbound like over a red star in toward the galactic globular cluster NGC 6569. These are DECAM data, and these are deduced within the Crowded Stellar Field Task Force. Thank you.
Cool, thank you. And Attila.
Hello everyone, my name is Attila Budi and I'm from the Konkoly Observatory, Hungary. So I'm part of the Hungarian Inkai contributing team, and you can see the other team members from the team, Robert Sabo and Tamás Lanár. So I'm primarily interested in machine learning methods to apply in astronomy and the classification and characterization of variable stars, mainly classical variable stars, positing variable stars, and eclipsing binaries. And I want to use the LSST data to study the different stellar environments, the positional contents, and the connection with the stellar environment, for example, the FE overage. And I'm here because I'm interested in the DP0 data, because I want to the LSST data, and of course I want to do the classification and identification of variable stars as our Inkai contribution. And on the left side you can see a beautiful parallel life curve, which is extracted from the DP0 dataset, but I'm right now waiting for DP0.1 because hopefully we can find the variable stars more easily in the future, because right now they are in the data set, but we don't know where. But probably we will have a catalog to identify the variable stars, and we don't have to randomly find and select stars to check whether they are variable or not right now. Thank you.
Thank you. I think that's our last profile slide for today. So thank you to all our delegate profile presenters. Thank you very much. Let's go back to, and also actually, since we're headed into breakout rooms, I can stop recording now.